Yes, good evening, ma'am.
Good evening, Pratima ma'am. So, good evening, everyone. Today is the day 4, and I'm going to discuss two things today. First is descriptive statistics using SPSS, and second, I'll discuss the one sample t-test using SPSS, right? So, I hope I can start the session, right? Ajay sir, shall I start?
Yes, ma'am, please. Thank you.
Yes, thank you, sir. So give me a second, I'm going to share my screen. Yes, I have shared my screen. Anyone, will you please confirm me whether it is visible or not?
Yes,
Yes,
ma'am,
ma'am,
it
it's
is
visible.
visible.
Yes, thank you, everyone. So, before proceeding to the inferential statistics, today I'll discuss the descriptive statistics, and in the inferential statistics, today I'll take the first test, that is one sample t-test. Okay. So, firstly, I'll explain you the descriptive statistics. So, in that, I'll explain you the agenda of the day. I'll try to explain you what is the statistics, what are the types of statistics. Then we'll discuss what is descriptive statistics and what are the methods of descriptive statistics. Give me a second. I think I forgot to close my WhatsApp. Just a minute. Yes. Yes. So this is all the agenda of the day. Firstly, today I'll discuss all these things, and then we will move for the one sample t-test. Firstly, I'll talk about what is the statistics. So, those who are belonging to the statistics field, or those who are, I think, knowing not very much in a better manner or in an expert manner, but those who are knowing about the statistics, they know there are certain steps starting from data collection to the interpretation of data. These all steps are included under the statistics. So we can call all these of things which I have just told. These are nothing, but these are the functions of statistics. So the very first step we can say in the statistics, that we can say the very first step is the collection of the data. So usually we can use two sources to collect the data. The primary source we can use and the secondary source we can use to collect the data. So primary source meaning is that when we are collecting the first hand data, or when we are going in a field and we are collecting the data, means when there is researcher is involved in the process of collecting the data, that type of thing is known as the primary data sources. Say for example, we can say the methods like we can use the questionnaire, we can say the interview, or we can say the observation. So these all can be the methods we can keep under the primary data sources. Second source of the data collection is the secondary data sources. So means when there is already information available and we are only accessing that information for our research purpose or research study purpose, that way we can call that these sources are known as the secondary sources, means already existing sources. Say for example, newspaper, magazine, websites, books, etc. We are considering all these things, government reports, bulletin, etc. So these all can come under the secondary data sources. So that way, using these two sources, we can collect the data, right? Further, after collecting the data, next step is you need to classify the data. So broadly, we can classify data into the two categories, the qualitative data and the quantitative data. So qualitative data means, say for example, we are having the data of gender, or maybe we are having the data of the education of the respondent or their occupation. So that such kind of data can be the qualitative data. Similarly, if I talk about quantitative data, so maybe say for example, the age of the respondent, then their weight, height, income, salary, etc. These all can come under the quantitative data. Also, if we have collected the data on any particular number form, that is comes under the quantitative data. So that way we can classify that on what particular parameters we have collected the data, and that parameter whether it is a qualitative one or whether it is a quantitative one. So that way we can easily classify the data, and it is a very important part, classification of the data, because on the basis of that further we are deciding which appropriate tool or test we can apply on such kind of data. After classifying of the data, the next step is the summarizing of the data. So to summarize the data, we can use the measures of central tendency. measures of dispersion, box plots, etc. So these can be the some of the methods which we can use to summarize our data. After summarizing the data, we can also go for the presentation of the data. So usually two format can be used to present the data. The first one is the table format. Second one is the graph. So either using the table, we can go for the presentation of the data, or using the graphs, we can go for the presentation of the data. After that, we'll go for the analysis of the data. Here we need to decide whether we will choose the parametric test or whether we are going to select the non-parametric test. So that is depending upon the criteria of the test and what type of data we are having. Also, what is the objective and hypothesis we are having. So accordingly, we will decide which particular test we are going to use to analyze the data. Further, after analyzing the data on the basis of whatever output we are getting from the applying of the analysis, we will now go for the interpretation of the data. So that is the must, because as we all know, without taking or without inferring anything from the data, data is nothing but it is just a kind of facts and figures we are having. So we need to process them, and on the basis of that process, we can say this is the information we are having, and then we need to draw the insights from that particular data. So that way, that data would be meaningful for us being a researcher. So these are the few steps we generally follow in the statistics. So I hope I'm clear on this. Am I?
Yes, ma'am.
Yes, thank you. Moving further, now we can divide the statistics into the two categories: descriptive statistics and inferential statistics. So today we will see both. Firstly, I'll discuss the descriptive and then I'll discuss the inferential. But here, for the namesake, I'm explaining you meaning of both. So descriptive statistics meaning when we are using or when we want to summarize the data. So in that case, we can use the descriptive statistics. That means with suppose we are having a large data set. So at looking on the data set, we cannot draw any inferences. But when we are applying any of the methods of descriptive statistics, like measures of central tendency, measures of dispersion, or the graphical methods, means I can say the measures of distribution, right? So some type of things if we are applying on the data, that way I can say we can draw some insights from the data, right? So it is known as the descriptive statistics, which will help us to understand the nature of our data. Further, if we are okay and we are knowing what type of data we are having, what is the nature of that data, in that case, further we will go for the inferential statistics. Inferential statistics is based on the probability theory. That means using the sample, we are trying to conclude something for the population. So we usually draw a sample from the population. Then on that particular sample, we are applying certain tests. And then whatever conclusion we are drawing from the sample, we are trying to generalize those particular findings on the population. That way, this is known as the inferential statistics. So this is the two main important part or types of statistics. I hope, am I clear on this? Am I?
Yes, yes.
Yes, thank you. Further, moving ahead, I think in statistics, those who are well versed with the statistics and those who have attempted statistics manually, they are knowing there are certain types of series available in statistics. I can say we can divide the series into the three parts: individual series, discrete series, and continuous series. Individual series means when we are having the raw data. Say, for example, I have collected the data of suppose height of the respondents, right? So in that case, I have not given any particular interval. I have directly asked, please state your height. So maybe some people are writing 5.2 inches, some are writing 5.8 inches, likewise. So that way we are collecting the raw data, or we are having only observations for the particular variable. That type of data is known as individual series data, right? So here you can read this particular column for the individual series. There is always one frequency for each item. There is no column for frequency. In this series, values are given in the definite break. So you can read this particular example. Say, for example, 1, 5, 9, 12, 34, likewise. So this is the example of individual series. Now, when we talk about discrete series, in discrete series with the or along with the observations, we will always have the frequencies. So that way you can see here when we are having these observations and along with that we are having the frequencies also. So that is indicating that 1 is coming 6 times in a particular series. Similarly, 3 has repeated 4 times in a series. 8 is coming 2 times in a series. So likewise, we can read this particular table or this particular form of the discrete series. So maybe if you have repeated observations, you can convert them using the discrete series using the observation and the frequency format, right? So that way this is known as the discrete series. Coming to the continuous series, so when we are having the data in the class interval form, say for example, if we are collecting the data of the age, so many a time we usually ask, what is your age? Maybe or we are asking your age, maybe in between 18 to 25, 26 to 35, 46 to 55, likewise, and more than 56. So likewise, we can ask the age of the respondent, because generally we are knowing this thing. It is very it is known as a bad etiquette if we are asking the age of a particular woman or a particular person. So generally, by keeping this particular thing in mind, we can use or we can ask the age in the form of intervals also. So this type of data would be known as the continuous series data, right? So here these are the 3 forms available in case of statistics. Moving further, talking about again descriptive statistics, as I'm going to discuss firstly descriptive statistics, we need to see here that using the descriptive statistics, we are defining population of the interest in terms of presentation of the data, summarizing of the data, and understanding of the data. So here we can apply various methods of descriptive statistics to get the understanding of these 3 things, right? So this way, this descriptive statistics help us to provide the basic information about the variables in a data set, and also it highlights the potential relationship between the variables. So means when we are knowing the basic nature of our data or basic characteristics of our data, that way we can ascertain that which kind of inferential statistics we need to adopt on our data or we need to perform on our data. So this is the meaning of, I think I forgot to ask you in the previous slide, this slide and this slide. So will you please confirm whether am I clear or not?
Yes, ma'am.
Yes, thank you. Moving further, this chart is a very important chart. Again, at the end of the session, I'll give you a poll. Maybe question can be from the slide, right? So you can read it here. When I talk about descriptive statistics methods, so under that, we can keep these 4 things, that is measures of central tendency, dispersion, distribution, and also the graphical method. We can keep under the descriptive statistics, right? So when we talk about graphical, means when we are interested for the data representation or data presentation, in that case, we can go for either bar or pie or histogram or scatter plot type of graphs, right? So when we will apply the bar plot or bar graph or the pie chart, so you need to know this thing always. On the basis of the nature of your data, you need to decide upon that which particular graph you will use or you will select to show your graphical representation of your data, right? So if your variable is of nominal or ordinal nature, means if you have measured your variable on nominal scale or on ordinal scale, in that case the suitable graphs are pie and the bar, right? Say for example, we have a data of gender or the education of the respondent, so suggestive one is either go for pie chart or either go for bar graph, right? Similarly for ordinal scale, say for example, I have collected the data of socioeconomic status of the respondent, so again better is rather than going for other charts, you can go for the bar chart, right, or pie chart. So means when the nature of your data is categorical, you can go for pie chart or bar chart. Then if you are having the data on interval or ratio scale, means when you are having the numeric data, when you are having the quantitative data, in that case you can go for histogram and scatter plot, and also box plot we can keep here in case of interval and the ratio scale data. Coming to the measures of central tendency. So again, on any of the data, it is not like that whatever type of data we are having, anything we can apply, either mean, median, or mode. No, it is not permitted. It is not correct also, right? So if you are having the quantitative data or numeric data or interval or ratio scale data, suggestive one is you need to go for the mean calculation. If you have a data on ordinal scale, you can go for the median. And if you are having the data on nominal scale, you can go for the mode. And also, if your data is skewed, say for example, you are having the data on the interval or ratio scale or numeric variable you are having, but that is showing you the skewed distribution, right? In that case, you can go for the calculation of median in terms of measures of central tendency. Talking about the measures of dispersion, so generally you can calculate standard deviation and variance in case of interval and ratio scale. Generally, this dispersion we are calculating in terms of only the interval and ratio scale variable, that is the numeric variable, right? Similarly, if we want to see the distribution of our data, if we want to see which type of distribution is showed by our data, in that case, we need to calculate skewness and kurtosis. And again, these two we can apply if we are having the numeric data, that is interval or ratio scale data. So this is very important to understand that what kind of data you are having, and in that case, which type of test or which type of statistic or descriptive statistics you are going to perform on such kind of data. So I hope, am I clear on this slide? Am I?
Yes, ma'am.
Yeah, thank you. Coming to the next, now generally we all have drawn these graphs in our school times, and some of us have drawn these things in even our college times also, right? So generally we are knowing there are two axes, x-axis and y-axis, because on paper we can only draw these two axes on a paper, right? X and y. So usually when we talk about graphs, so we keep usually the dependent variable on the y-axis and the independent variable on the x-axis. So whatever is your independent variable, you will always keep that variable on the x-axis, and in the dependent variable you will always keep on the y-axis. So that way you will decide firstly which variable you are taking as a dependent, which variable you are taking as an independent, and accordingly you will decide the axis for your that variable. Further, talking about x-axis, so if your x-axis meaning the independent variable, right? So if your variable is discrete, in that case bar and pi I have already explained you, but if your variable is continuous, you can go for histogram, ogive, or the frequency polygon, right? So these can be the suggestive graphs or charts in case of continuous variable. Now, talking about the presentation of data, already in the previous slides, I have told you this thing that for presentation of the data, we can generally prefer two things, either the tables or either the graphs. So here you can see, if we are talking about table, so table will indicate you the frequency distribution of your data, right? And in case of graph, using the measurement of scale means on what type of scale you have measured your variable, or what is the type of your variable, you will decide which graph you are going to plot, right? So I have already discussed these things. For the nominal and ordinal scale variable, we will go for bar graph and pie chart. And for interval and ratio, generally we can go for histogram, scatter plot, or polygon, or box plot also, right? Further, talking about measures of central tendency, I think all of us are aware about the formulae of mean, median, and mode. So in a hurry, I'm just explaining you all these things, that when I talk about mean is generally the known as the aggregate measure of a particular data point or data series, right? So generally how we can calculate it, whatever number of observations we are giving, so we can sum all the observations and then we can divide them by the total observations. It will always give you the mean value, right? So it is known as the aggregate measure, means it would be a single value which will represent the entire data, right? So that way, measures of central tendency, from the name itself it is clear, measures of central tendency. So we need to have a central point of the data, and using this formula we can get that central point. Coming to the next, median is known as the positional measure, means Using the median, generally when I talk about the definition of median, median is what? Median divides the series into the two equal parts, right? One part would be the containing all the less than value from the median, and second part would contain all the greater than value from the median. So that way, this is the definition of median. Generally, this is the formula we can use to calculate the median. But usually for the manual calculation, you need to arrange your data into either ascending order or into the descending order, and then you can apply the formula to get the value of median. Mode is very simple. It is nothing but it is the highest, or it is a value which is occurring most number of time in your data, right? So that way, for any particular data point, if the highest frequency you are getting, that particular value would be the mode value for your series or your data. So that way, these are the three measures that we can manually calculate, but also using SPSS or other softwares, we can directly get these values. Now, measures of dispersion. So this is a very important aspect of any particular data, because when we talk about the measures of dispersion, it indicates the scatteredness in the data, means how much is the spread in your data. Generally, this scatteredness or spread we will calculate from the median, from the mean value. That means from the mean, how much is the scatteredness or spread in the data available. Say for example, I'm giving you a simple series. You all can imagine, or you all can write. Suppose we are having a series with the 5 data points. Say for example, 1, 2, 3, 4, 5. Right. So if I want to calculate median for it, so median would be what? The we need to add all these 5 observations, and we will divide that sum by the 5. So the sum would be 15 by 5. It would be 3. Right. So from 3, what is the spread, means from that 3 we will see how much is the deviation of the remaining data points. So we can see from 3, I will check the distance of 1. So 1 minus 3 is minus 2. 2 minus 3 is minus 1. 3 minus 3 is 0. Then 4 minus 3 1, and then 5 minus 3 2. So that way we are checking that how much is the spread in the data. So for the purpose, firstly you need to have that central value, maybe a mean or maybe a median. But in case of standard deviation and variance, we always calculate the mean value. So it is very important to have, because this will indicate you the deviation in your data or scatteredness or spread in your data, and that way we can ascertain whether the data is normally distributed or not. Yesterday, when I was talking about the normal distribution curve, I have explained you this thing. Miss, I think I didn't explain you yesterday this thing, but today I'm including that thing. Yesterday, I think I have shown you the graph, that is the bell-shaped curve, right? So how we can calculate or how we can find that curve? So for getting that bell-shaped curve, we need to have two things. First thing is the mean value. Second thing is the standard deviation value. So for if we are having any data series, right? So for that data series, we can easily calculate the mean, and we can easily calculate the standard deviation also. So using these two figures, we can find that bell-shaped curve. So generally, maybe if you have heard about mean plus minus 1 sigma, mean plus minus 2 sigma, mean plus minus 3 sigma. So this is helping out you to find that bell-shaped curve. So the mean value, so once in the mean value, we will add the standard deviation, and then once in the mean value, we will subtract the standard deviation. So that way we will get our range. Similarly, in the mean value, once we will add 2 times of standard deviation, and we will subtract 2 times of the standard deviation. So that way we will get the other range. And likewise, plus 3 and the minus 3, means plus 3 sigma and minus 3 sigma. So likewise, we can get that particular shape, that is bell-shaped curve. So that is why the measures of dispersion or understanding of this particular measure is very important from the point of view of the normality. I hope, am I clear? Am I?
Yes, ma'am.
Yes, ma'am. Coming to the next, now we can divide broadly. I can say there are 2 types of measures of dispersion: absolute measures of dispersion and relative measures of dispersion. Absolute will give you a figure or the number value, but relative measures will give you the coefficient value. Means this would be in the point form, or it can be in the percent form. So relative measures are generally most of the people usually preferring these to compare the two series. So say for example, I don't know how many of you are from the statistics background, but if you are, or if you in any of your academic journey, if you have studied the coefficient of variation, so maybe you people are knowing this thing. If we want to check consistency in the data, say for example, I have the share prices of two companies. I want to check which share prices are more consistent, right? So what I can do, I can calculate the mean value of the share prices for both the companies. I can calculate the standard deviation of the share prices of both the companies, and then using the formula of coefficient of variation, that is standard deviation divided by mean into 100, we can calculate coefficient of variation or variance, right? This is the figure which will indicate the consistency. So say for example, suppose the first company is company A, second company is company B. So for example, for company A, we are getting the coefficient of variation as 25%, and for company B, we are getting coefficient of variation as a 15%, right? So we can easily compare these two percentages, and we can conclude this thing that generally for the coefficient of variation, interpretation is that for whatever series the coefficient of variation is less, that series would be the more consistent series. So it is quite clear that company B coefficient of variation figure is 15%. So I can call company B shares are more consistent in comparison to the company A. So that is why, means relative, meaning we can use these measures to compare two series, right? Absolute measure will always be in figure form. This would be in a point, decimal point, or maybe in a percent form, right? Is it clear? These are the various formulae. Using that manually, we can calculate these absolute and also the relative measures of dispersion. So, am I clear on this? Yeah. I'm not going in much deep because we need to get the clarity about 2-3 things only in case of measures of dispersion, right? So that is why I'm not discussing much these things. Coming to the next point, many a time it happens. Suppose we want to join a company. Suppose I'm in a search of I'm a search of a job, right? So suppose I have a range of salary of the two companies. You can see here. Suppose company A, the range is 16. For company B, the range is 16. But I'm not knowing what is the lowest and the highest salary in the company, because range is what? Range is, I have shown you previously. Formula for range is what? It is maximum minus minimum, right? So now if I'm knowing this thing, that the first company, it is offering minimum salary as 4, maybe it can be 4 lakhs or something, and the highest package is suppose 20 lakhs, right? So that way I can get a difference of these two. It is giving me the range 16 lakhs. Similarly, one company is offering minimum 24 lakhs and highest offering is 40 lakhs. So that way again the difference you can find 16. So if I'm knowing the range of the salary in both the companies 16, so that way it is quite difficult for me to take decision. But when I'll use the coefficient of range, it will give me the clear picture, right? So what is the formula of coefficient of range? It is the maximum minus minimum divided by maximum plus minimum. So for the both the salary, we can for both the company, we can calculate this coefficient of range, and here we can find 0.67 and 0.25. So it is quite clear, as it is a case of dispersion. So whatever is the least figure, that is indicating the more consistency in that particular company's salary. So here we can see 0.25 is less than 0.67. That way we can conclude this thing, that company Q is more consistent in paying the salary in comparison to company P. Got it? So such type of these types of figures can help us out to take decisions even in our real lives also. Moving further, talking about the interquartile range, again, it is a very important parameter. As I think I have shown you the figure of Boxplot. So it is similarly, you can see Boxplot is nothing but this is the interquartile range only. You can see in the Boxplot I have shown you there would be one box, right? So this would be that one box. This middle point would be your median value, which I have shown you yesterday, right? This would be your lower quartile, this would be your upper quartile. Got it? So that way, interquartile ranges formula is Q3 minus Q1. So Q3 means 70% of your data, means from here to here. This would be your Q3, and Q1 is this to this. So from 75%, I am removing this lower 25%. So that means the middle 50% would be your interquartile range. I hope, am I clear? Am I? I'm clear?
Yes, ma'am. But can you please explain the two slides before? There is one term QD. So can you please tell what is QD?
This,
Yes.
I think I have just explained. This is the quartile deviation. So Q3 minus Q1 divided by Q3 plus Q1. Third quartile minus first quartile divided by third quartile plus first quartile. Fine?
Yes, ma'am.
Okay. So I think this is the figure which I'm not going into. This would be little more technical for you people. So right, directly I'm coming to the normal distribution. Although yesterday I have discussed so many things about normal distribution, but again for the sake of descriptive statistics, I'm just giving you a brief of normal distribution today. Here you can see generally now, as I said yesterday, for normal distribution, generally we can understand the normal distribution using the bell-shaped curve. If we are getting a perfectly bell-shaped curve, that way we can call that data is the perfectly or the mesokurtic data. Mesokurtic means the perfect distribution of the or perfect normal distribution of the data. But if such kind of graphs, such kind of shapes we are getting in the data, so that way it is showing me if the it is very narrow, the bell-shaped curve is very narrow, it is showing that their standard deviation of the data is very small. But if it is very what I can say spreaded, in that case we can call the standard deviation is bigger in comparison to the other data, in comparison to the other data series, or in comparison to this series I can call the standard deviation is greater than, or if I compare this series from this, I can call this the standard deviation is less than in the series. That means there is less dispersion in the series and there is more dispersion in the series. So this way, using the shapes also we can understand the distribution, and also we can understand the deviation in the data. Next, generally the thing which I was telling you previously, plus minus the thing which I have said to you, you can see, as I said yesterday also, I have shown you a graph. I said usually the middle point of this bell-shaped curve is nothing but this is the mean value, right? So generally mean we can indicate by the mu. This is the population mean. Mu indicates the population mean, right? So mu plus minus 1 sigma, right? So if suppose you are having some mu value, suppose it is 10, and you are having suppose standard deviation value as 1. So it is mu plus minus 1. So once mu is 10 in plus 1 sigma. So 1 into 1, 1. So 10 plus 1, 11. Similarly, 10 minus 1, 9. So that way this would be 9, this would be 11. Similarly, plus minus 2 sigma. So 10 plus 12, sorry, 10 plus 2, 12, and 10 minus 2, 8. So likewise, this way you can decide upon the shape of this curve. So generally, if I talk about mu plus minus 1 sigma, it contains around 68.2% of your data points in the normal distribution curve, right? Similarly, mu plus minus 2 sigma means from here to here, this range, this includes around 95.4% data points of your data. Similarly, mu plus minus 3 sigma, it includes approximate 99.7% of your data points, right? And remaining 0.3 means 0.15 this side and 0.15 this side. So above plus minus 3 sigma, remaining 0.3% we can say can come at both the sides, 0.15 this side, 0.15 this side. This is in case of perfectly normally distributed data. Is it clear to everyone?
Yes, ma'am.
Yes, thank you. Now, yesterday also, I think I have discussed this thing. I'll give you a brief in hurry. I'll just give a recap of this. So this is known as when the right tail is greater than left tail, we can call it as a positively skewed data. In case of this, generally, mean is greater than median, median is greater than mode. In case of perfectly symmetrical distribution or perfectly normally distributed data, mean, median, mode, all three would be equal. In case of negative skewed data, that means when your left tail is greater than your right tail, usually your mean is less than median, median is less than your mode. That means mode would be the highest value in your data. In that case, you can call this as a negatively skewed data. So that way you can understand the asymmetry in your data using this particular three figures, mean, median, and mode. Talking about kurtosis, this would be the study of the peak and about the tail of your data, that what is the peak of your data and what is this what is the story about your tails, whether the tails are very heavy or tails are lighter. So that way we can study the kurtosis. So you can find here the black shape is indicating this is the mesokurtic data. This is the perfectly normally distributed data. This green, this yellow, sorry, this bluish in indicating leptokurtic, means this is the positively skewed data. Here tails would be heavier. That means most of the data points are falling at the tails, right? In case of platykurtic, the tails are little thicker, or I can say these are lighter. That means there would be less data points will fall at the tails in case of platykurtic, and this is known as the negatively skewed. So red one is known as negatively, blue one is known as positively skewed, and this is the perfectly normally distributed data. Okay, so I think yesterday I have already discussed all these things. Generally, for the perfectly normally distributed data, skewness should be 0. Kurtosis should also be 0. But as I said, in the real world, it is very hard to get a perfectly perfect data in which skewness and kurtosis is coming as 0. So in that case, we can keep certain threshold value. So those threshold value can be plus minus 2 or plus minus 3, depending upon how much you are bothering about the normality of your data. If you are much bothered about the normality, you can keep it as plus minus 2. If you are not much bothering about your normality about of the data, in that case you can keep it as plus minus 3 as well, right? Now methods also, I think I have explained you. So this is about the now how you can calculate descriptive statistics in SPSS. So these are the 5 ways: frequencies, descriptives, explore, cross steps, and means. This is all I'll show you once we are moving towards the SPSS. So this is all for the descriptive statistics in the conceptual format from my side. If you have any queries, you can ask me, or else I'm going to share my screen for the next thing. Any doubts so far?
No, ma'am.
Okay, fine. Thank you, ma'am. So coming here I'll discuss now, although yesterday also I have shown you, but we have discussed only 1-2 steps of the descriptive statistics. So here I'll explain you how you can calculate or how you can find the descriptive statistics for your data. So firstly, you need to go to the analyze menu. Then you can go to the descriptive statistics. In this, these are the various ways available. You can find frequencies, descriptives, explore, and then cross step. These 4 are coming here. Last would be coming here in the compare means, right? So I'm talking about the descriptive statistics, and firstly I'm checking on I'm clicking on the frequencies. So I expect everyone, those who are performing along with me, yesterday I have shared a file with the name bank loans, right? I'm expecting all of you, please open it. And once you are opening it, give me a signal so that we can proceed further for applying the descriptive statistics. How many of you are performing along with me? Yes.
Myself.
Okay, Girja ma'am is performing. That's great, ma'am. And who else?
Ma'am, I'm just trying. I can't say, but I'm just trying.
Asmeet ma'am, right?
Yes, ma'am.
Okay, that's great. And what about others? Yes. What about others? Nobody else is performing along with me? Yes. No one? Only 2 people are performing along with me, is it? One more people raised the hand. Prema ma'am, I think. That's great. That's good. It's a motivation for me that people are performing along with me. I think Jyotsna ma'am also, Riddhi ma'am also. That's great if you are performing. So I request all of you, please open this particular sheet. If you have opened, tell me so that I can proceed further. Is it done?
Ma'am, please, 1 minute. Just
Okay,
one.
I'm giving you a time. Meanwhile, I'll share one more file with all of you because I need to discuss one sample t-test also, right? So I forgot to share a sheet. Meanwhile, you are opening, I'll share a sheet with all of you. How many of you are ready?
Yes, ma'am.
Ready? Okay.
Ready.
Yeah. Give me a second. I need to open the sheet which I have to share with you. I need to check in which sheet the data is available. Okay. Today I forgot to share a sheet along with all of you. Yes, this I can share. Something else. Okay, give me a second. I have found the file. Yeah, I have shared one more file with all of you for the t-test that we will see afterwards. Firstly, I'm coming here and we'll discuss the descriptive statistics. So I suggested all of you to go to the analyze menu, select descriptive statistics and go to the frequencies. Is it fine? May I click on frequencies?
Yes, ma'am.
Yes. Once I have clicked on frequencies, we are seeing here that the frequencies dialog box is popping in front of us. We need to see all the variables of the sheet is listed at the left hand side. We need to decide upon for which variable we want to calculate descriptive statistics, right? So suppose I'll suggest all of you go with the level of education first and shift it to the right hand box in the variables box. Done? Shifting is done.
Yes, ma'am.
Yeah. Then you can go to the yes, thank you, ma'am. Then you can go to the statistics button. So before proceeding further, this is my question from all of you. One variable I have shifted, that is the level of education, to the right hand box. May I know how many of you can tell me that what would be the type of this variable?
Statistics, ma'am.
No, I'm asking,
Yes.
just a minute, I'm closing this. I'm asking you, I have shifted the level of education, right? From left box
Qualitative.
to the right box.
Yes, ma'am.
Yeah,
Qualitative variable.
yeah, I think who has given the answer?
Hi, Prema.
Prema ma'am. Very correct. Very good, ma'am. Thank you. So level of education, the type of the level of education variable would be the qualitative in nature, or I can call this would be the ordinal skill variable, because when we talk about education, so suppose some of the people have opted or are having the graduation degree, other set of people are having the post graduation degree. So that way I can say there can be some order also, right? I can categorize people on the basis of their education, and also there can be some order because this is the education, and education would always be in increasing order, right? If I am a 10th standard student and someone is of 12th standard student, it is quite obvious. I can say 10th standard people order would be little lower than the 12th standard order, right? So that way, whatever categories we are having there, we can set certain order also. So that way, this is the ordinal scale variable. Now for this variable, which would be the appropriate statistics? Yes.
Median, mode.
Mean. Sorry.
Okay. Who
Mode?
said mean? Okay.
Ma'am, Asmeet.
Asmeet, ma'am. Okay. And who said mode?
Prema.
Prema,
It's
ma'am.
me, Girija.
Girija ma'am said mode, right?
If it is
Median,
ordinal,
mode.
median is there, ma'am. If it is yes, if it is ordinal, then we'll do median.
Yes, either median or mode can be the suitable descriptive statistics. Mean
Yes.
is not at all suitable statistics in case of ordinal scale variable, because we are knowing this thing. Suppose we are having only 3 respondents, and one is belonging to, suppose, UG category, one is again from the UG category, and third one is from the PG category. So I have given 1 for UG and 2 for PG. So if I'm adding these numbers, 1 plus 1 plus 2, so it is coming as 4. Average would be 4 by 3, it is 1.33. So 1.33 is representing what? Nothing, because in our coding I have given 1, 2 and 3 only, or 1 and 2 only. So 1.33 is coming nowhere. Got it? So that way, mean is not at all a suitable measures of central tendency here. So in case of this, we can go with mean, median, and mode. And also in this dispersion, you can see we can again, as we are having the ordinal scale variable, so standard deviation, variance, and range is not at all suitable measure of the dispersion. But if we want to calculate minimum and maximum, that we can do, right? So that you can do, but again, as I said, might be possible there are only 5 categories available. So still, to check what is the type, what is the minimum qualification and what is the maximum qualification in the data set, for the purpose you can click here minimum and maximum also. Again, there would be no use of skewness and kurtosis, as this is the ordinal scale variable, right? So you can press here continue. Is it fine? Everyone has checked these 4 boxes. Understood why I have checked all these 4 boxes? My pace is okay.
Yes, ma'am.
Because
Yes, ma'am.
I speak little faster, so you can interrupt me in between if you're feeling like. Okay, may I continue?
Yes, ma'am.
Yes, ma'am.
Yes. After that, we are not going into the chart right now. We are only want to see the frequencies and the descriptive statistics for this particular variable. So we are pressing OK here. So once I am pressing OK, you would be able to see the output window. It is showing me valid cases are 850. There is no missing value available in the data. Median is coming as 1, mode is coming as 1, maximum value is 5, and minimum is 1, right? Coming to the next, here you can find we were having total 5 categories in the education. First category was did not complete high school. So how many of the people, those who have not completed their high school? 460 people, right? Similarly, high school degree or means out of 850 to 35 people are having the high school degree. Similarly, how many of them have the college degree? So 101 are having the college degree. Or maybe they have not completed their college. I mean, I can say this thing. Then college degree, 49 people are having college degree, and postgraduate degree, 5 people are having the postgraduate degree. So likewise, you can understand this particular thing. Now there can be the role of percent. So percent calculation is quite easier. 460 divided by 850 into 100 will give you this percent. And likewise, you can see the valid percentages also. Then talking about the cumulative frequencies or cumulative percentages. So I think it is very easier to understand. Those who are from the statistic, those who have calculated cumulative frequencies, they are knowing. For the first category, whatever is your percent, that would be your cumulative percent, right? For the next category, this would be added to this 27.6. That would be 81.8. Similarly, 81.8 plus 11.9 will give you 93.6. 93.6 plus 5.8 will give you 99.4, and 0.6 plus 99.4 will give you 100%, right? So that way, this is the cumulative percent, right? Is it clear?
Yes, ma'am.
If I am asking you how many of what is the percent, means how much percent of the respondents are having at least are having at least, suppose, high school degree. So what would you will say?
Ma'am, are you asking about the frequency or percentage?
Percentage.
That's 27.6, ma'am.
27.6. Okay. My question is, how many or what is the percentages of the people respondent those who are having at least high school degree?
Acha, at least, okay.
Yes.
81.8.
Yes, ma'am. 81.8, yes.
Yes, very correct. So you can understand the meaning of cumulative percent here, right?
Yes,
Right.
ma'am.
So that way, this is the role of the frequency under the descriptive statistics. Now we are moving further. I'm using this shortcut handle here to reach. No, I do not want to use this. So again, I'm going to the analyze menu, descriptive statistics. This time you can click on the descriptives. I suggest you go to the next point, descriptives. Once I have done this, now this time suppose I am shifting my household.
Ma'am, can you please repeat the question what you asked?
I asked how many percentage of the people are having at least high school degree.
So that means it did not come as 81.8 because 54.1 haven't completed this high school itself. And then how come the high school, at least high school degree means it will not come as 81.8. I think
Yeah,
it's only,
it should be subtracted. It should be subtracted from
yeah,
this
it should be
figure.
subtracted from
Yes,
54.1.
correct.
Yes.
It is subtracted from this. I think someone of you have told me that 27.6 also.
27.6 is the right one.
Yeah, 27 of 6 is the correct percent. Correct. Now going to the analyze menu. Now I suggest you go to the descriptive statistics and then go to the descriptives. Is it fine? Everyone fine with this? May I press
Yes, ma'am.
descriptives? Yes.
Yes, ma'am.
Now this time I suggest you go for the suppose income. I suggest you go for the household income in thousands, shifted to the variables box. Done? If you have shifted it to this box, you can click on the options button here. In the options button, you can find some of the check boxes are already ticked by the SPSS. These are already checked by SPSS. These are the by default options. These are the by default output you will get for your variable, right? So as income is a numeric variable, so mean is fine. Standard deviation is also fine. Minimum and maximum figures are also fine. If you want to get the variance, that also you can check. And we can check kurtosis and skewness also, right? Is it fine? Whatever is the by default options, I suggested you go with some more, with some two more options, kurtosis and skewness. Is it fine?
Yes, ma'am.
Then you can press continue, and then you do not need to do anything else. You can press only OK to get the output. Once you are pressing OK, you would be able to see you are getting a small table containing all the things which we have checked there or which were already checked by the SPSS. So for the household income, you can check total 850 observations we were having. Minimum income was 13, maximum was 446. Minimum statistic was 40. Mean income was 46.67. Standard deviation of the income was 38.54. Skewness figure was 3.7. Kurtosis figure was 22.486. So that way, these are the various figures we are getting. In looking at these figures, we can also conclude something about the normality of the income. Using the kurtosis and skewness, I think yesterday we have also seen the same variable, I guess, right? I think the figures are quite similar to me. So maybe we have seen the same example yesterday, and the figures are again saying us to this that the variable is not normally distributed. Is it clear to everyone?
Yes.
Last thing I'll explain you. You can go to the again analyze menu, then go to the descriptive statistics, and then this time you please click on the third option, explore. Then is it fine? Then you
Yes,
can
ma'am.
then you can shift your household income in thousands in the dependent list box. In the dependent list box, usually you need to keep the numeric variable, right? And then suppose there is only no, there is one more categorical variable available, previously defaulted. So this I am shifting to the factor list box. Done? Is it done?
Yes, ma'am.
Now you can go to the statistics. It will give you the by default option. I'll suggest you do not touch anything here. Only press continue. Then go to the plots. Here, rather than checking the stem and leaf, you can check the histogram, and then you can check normality plots with tests. These two things you need to check here. You need to decheck or deselect the stem and leaf, right? And then you can press continue. May I?
Yes, ma'am.
Yes, ma'am.
Now you can press OK to generate the output. So once you will press OK, you can see in the, as we have shifted the default variable into the factor list box, so descriptive statistics will come according to the categories of your factor variable. So in the factor variable, there were two categories, yes and no categories. So you can see here the household income in thousands. So previously defaulted people. So these people have not defaulted previously. On the basis of this, you can see their mean income is this. This is the 95% confidence interval of mean values. 5% thing. I think yesterday I have explained you all this. 5% means we were removing 5% outlier from both the sides, and that way we are getting the mean figure. This is the median, variance, standard deviation, minimum, maximum range, interquartile range, skewness, and kurtosis figure. This is for the no category. Similarly, for yes category, we can read. Coming to the normality, you can check for the normality, you can check for yes and no category both. So we have, I suggested you for up to 1000 sample size, we can report Shapiro-Wilk, right? So we are using Shapiro-Wilk for both the categories. So we can see for no category and yes category both, the significant value is less than 0.05. So that way we can conclude that variable is not normally distributed, right? Going down, looking at the histogram, again you can see for the defaulter category, no, means the person, those who have not defaulted previously. For them, if we were looking at the income, we can see that income is positively skewed. Similarly, for yes category also, we can see that income is positively skewed. Now, the QQ plot for no category is saying that income is positively skewed. Similarly, for yes category also, we can see QQ plot is saying income is positively skewed. Detrended, you do not need to discuss. Coming to the last option, that is the box plot. So for both the categories of the previously defaulted no and yes, you can see income distribution. So you can find here that for both the categories, we can say this thing, that there are many various outliers available in the data, right? These are the asterisks. Asterisks are the significant outliers, means they will definitely impact your results, right? So this would be your call if you want to remove them. So this way, this is the way of finding the descriptive statistics using the SPSS, all the three ways I have explained you. So I think, is it fine? Any doubt so far? If any doubt, you can ask me, or else I'll go for the next thing, that is the one sample t-test. Any doubt?
No, ma'am.
No, ma'am.
Okay, thank you. So coming to the next portion of the session, I'll discuss now one sample t-test. So as I said, one sample t-test is the kind of inferential statistics. Means using the sample, we are trying to infer something about the population. This is known as one sample t-test. Now, as I said, one sample t-test is a parametric test because in the one sample t-test, we are considering the parameters of population. So I'll show you in the upcoming slide the formula. In the formula itself, you can see what are the parameters we are using in the particular formula, right? So one sample t-test we are using to determine whether the sample mean is statistically different from the known or hypothesized population mean or not. So means when we are comparing sample mean with the population mean, in that case we can go for the one sample t-test, right? So the variable used in the test means whatever variable we are considering in the test to compare the means, that variable is known as the test variable, right? So the test variable is compared against the test value, and this test value is what? This would be your population mean value, that is the hypothesized mean value, right? So generally those who are from the statistics, I think many of us have heard this thing, that there is z test also, there is t test also, right? So there is a difference when to use z test, when to use t test. Some people are saying usually using the sample size, like if sample size is less than 30, we can go for the t test. When sample size is greater than 30, we should go for the z test, right? But when we talk about SPSS, in SPSS there is no test like Z test. Only T test is available, and the basis of the T test is that if you are not knowing the standard deviation of the population, means when the standard deviation of population is unknown to you, in that case you should apply the T test, because usually the using the central limit theorem in the SPSS, it is written, when we increasing the sample size from 30 and we are going beyond 30, that way probably this is a chance we can achieve the normality of the data. So for the purpose, it is generally suggestive. If you are using SPSS, so as there is no option, you need to always only apply the t-test. And also we are knowing this thing, many a time it happens, whatever data we are collecting from the market or from any of the population, generally its standard deviation is not known to us. So that is why we are using the t-test. Now, procedure of the t-test is generally you need to define your null hypothesis. Also, you need to define your alternative hypothesis. Then you need to decide your level of significance, that is the alpha value. Then we will calculate the degrees of freedom. Then we are stating our decision rule. That means if the alpha value is less than, or if the p value is less than alpha values, whether you are accepting or rejecting the null hypothesis, that you need to decide upon. Then we will calculate t. So we will do calculation t of the t would be done using this formula. So as I said, mu is used here. Mu is known as the population parameter. So once we are using the parameters of population, that type of test is known as the parametric test, right? So further, using that, after calculating that, you need to state your results, whatever decision rule you have set. On the basis of that, you will state your results and you will conclude your results also. Further, you can see for each and every test, the table is always available in the statistics. So for one sample t-test also, this would be the table of the t-test. Using the two parameters, degrees of freedom and level of significance, you can find the value of t, right? Now, the hypothesis for the one sample t-test you can find here, that for the null hypothesis you can see mu is equals to x bar. Mu is the population mean, x bar is the sample mean. So when I'm saying population mean is equals to the sample mean, alternatively I'm saying population mean is not equal to the sample mean. So meaning of this is, means population mean can be less than sample mean, or population mean can be greater than sample mean, but I'm not clearly stating whether it is greater than or less than. I'm only saying it is not equal to. So in that case, this is the case of two-tailed test. Means both the tails are involved here. It can be the greater than also, it can be the less than also. But then if I am making my null hypothesis like mu is greater than or equal to x bar, means population mean is greater than or equal to sample mean. and alternatively I am writing mu is less than x bar. So in that case, this is the one-tailed test, right? And when I'm saying mu or the population mean is less than, this is the left-tailed test. Then if I'm writing mu is less than equal to x bar, and alternatively I'm saying mu is greater than x bar. So in that case, we can say this thing that this is again a one-tailed test, because I'm clearly saying that mu is greater than x bar, and this is the right-tailed test. So this is, you can see using the graph, if I'm talking about this particular thing, it is indicating us that both the tails are involved here. So this is the, if both the tails are involved, that means rejection reason will fall at both the end of the tails, right? And this would be the acceptance reason of your null hypothesis. Similarly, for the one-tailed test, you can see, if I'm talking about the left-tailed test, so the rejection reason will fall at the left tail, and remaining will become your acceptance reason of your null hypothesis. Similarly, in case of right-tailed test, the rejection reason will fall at the right tail, remaining will become the acceptance reason of your null hypothesis. So now, how you can formulate your null hypothesis in case of one sample t-test. So here you can see, when I'm writing, there is no significant difference in the sample mean and population mean. So this would be the case of your two-tailed t-test, right? Now when I'm writing sample mean is significantly less than, or I'm saying sample mean is significantly more than population mean, so this would be the case of one-tailed t-test. So is it clear so far, whatever I discussed? May I proceed, or any doubts so far?
No, ma'am.
Yeah, thank you. So now, most important part, assumptions of one sample t-test. So in case of one sample t-test, first assumption is your dependent variable. As it is a case of one sample means you will have only the one variable, right? And what would be the variable? That variable we will treat as a dependent variable, right? So the dependent variable which we are having, it should be continuous, means it should be either measured, either measured on interval scale or on ratio scale, right? So the dependent variable should be numeric in nature. Then coming to the next, the observations are independent of one another. So again, this can this particular assumption of the t-test can be met if we are collecting data from one person only once. So that way, using these are the two assumptions, and next two assumptions are the dependent variable, means whatever the single variable we are having, that should be normally distributed, and there should be no significant outliers in your variable. So using the histogram, as I have explained you previously also, when I was discussing the descriptive statistics, using the histogram, we can check whether the variable is normally distributed or not. Also using the box plot, we can check whether the significant outliers are present in your data or not, right? So I think this is about the meaning, or this is about the QQ plot, how you can explain or how you can understand your QQ plot. So this is the histogram, and along with that, this is the QQ plot. If all the data points are following your fitted line, so this way you can call it is a perfectly normally distributed data. But if your data points are showing this type of QQ plot, it is indicating this is a positively skewed data. If your data points are showing such kind of distribution along with or across the fitted line, you can call it as a symmetric data, but with flat or the fat tails, means most of the data points are coming on the tails, right? Negatively skewed data, in case of that, you can find such kind of curve below this particular fitted line. Okay. Now, procedure I'll explain you. I'm moving towards to the SPSS now. Any doubt? May I proceed further?
Yes, ma'am.
Yes, ma'am.
Yes. So I think file I have already shared with all of you, right? I suggest you to open the file, click on the open data. Wherever is your file, you can go in that particular folder. I'm locating my folder here, and here I'm changing this file type. I think this is this particular file which I have shared with all of you. I hope you people are performing along with me, right? Yes. Okay, I think my data is not opened yet. It is taking some time. Now you can see my sheet is, I need to open this particular sheet. In that there is a data of IQ and height. So I suggest you open this particular worksheet. Maybe I think 2-3 worksheets are there in that particular file. You need to go with the first sheet, one sample t-test, right? And then you can press OK. Once you will press OK, you would be see the data in the data view of your SPSS, right? I'm removing this. Yes. Done. Okay, everyone has opened it. May I proceed further?
Yes, ma'am.
Yes. So if you have opened this, firstly, we will check the assumptions. So the first assumption was your variable should be, the dependent variable should be the numeric. So here, firstly, I'm taking the IQ, right? So IQ is a numeric variable. It is very well known to everyone. So that is why I can say first assumption has been met by my data. Second assumption was you need to collect the data from every person, every respondent only once. So maybe I am assuming this thing that from each and every person I have collected their IQ score only once. So that way 2 assumptions we have checked. So this, looking at the data and looking at your collection procedure, you can meet first 2 assumptions of your t-test. Is it fine? May I proceed with the next one? Yes. Yes. Now we will check normality and outliers. So I'll suggest you go to the analyze menu, then descriptive statistics, and then go to the explore. And here shift your IQ variable to the dependent list box. Is it fine? Pace is okay. May I proceed?
Yes, yes.
Repeat.
Yes. From where, ma'am?
How to choose this one?
Okay.
From
Go
which
to
one?
the analyze menu.
Please report.
Okay. Go to the analyze menu, then descriptive statistics, and then explore. Fine. May I click?
Yes, ma'am.
Yes. You can click this. Then you can shift your IQ variable from left box to the right box using the arrow key. Means you need to shift your variable in the dependent list box. Is it done?
Yes, ma'am.
Then you can press the first button, statistics. But what is the by default option? I'll suggest you go with it. I think now you people would be used to of it, right? So you can press continue. Then you can press plots button. Here, stem and leaf, deselect, select histogram, and select the normality plots with test. Is it fine? May I press continue?
Yes, ma'am.
Yes. Oh, I have. Yes. Yes. So this is all you need to do here, and then you can press OK to generate your outputs. So once I am pressing OK, I am getting the various tables in the output window. It is showing me total 30 observations for IQ I am having. There is no missing value, so total observations are 30. I think I'm not explaining this. This is what we have just discussed. We will only look at the skewness and the kurtosis figures. So you can find these are the little small figures, -2, -0.261 and -0.718. So if the range we are taking is -2 to +2, so this is coming in the range, right? So maybe we can conclude that the IQ variable is approximately normally distributed. Is it fine? From skewness and kurtosis, explanation is clear. May I proceed?
Yes, ma'am.
Yes. Coming to the test of normality table, you can find the Shapiro-Wilks test, right? So significant value is coming as 0.3 0.317, which is greater than 0.05. So that means we are not going to reject the null hypothesis, and our null hypothesis is stating that the variable is normally distributed. That means I can conclude that IQ is normally distributed. Is it fine?
Yes, ma'am.
Yeah. Coming to the next, talking about the histogram. Histogram, I think it is little trickier to look at the histogram and conclude anything, but you can double click on this and you can keep this distribution curve on your histogram. This is, you can find here in the toolbar. I'm clicking on this and then I'm closing this and then I'm closing my chart editor also. I can find, means it is showing me that approximate or almost most of the bars are coming inside this particular curve. So maybe I can say this thing that my variable is approximately normally distributed, right? Using this QQ plot, almost the points are almost following this fitted line. Maybe I can conclude again here that my variable is normally distributed. Coming to the last box plot, if any of the circles or asterisk I am getting beyond these whiskers, so in that case I can conclude that there is some outliers available in my data. But here I am not getting any of the outliers or any of the circles beyond these two whiskers. So maybe I conclude this thing that there is no outliers available in my IQ variable. So that way we have checked all the four assumptions of the variable IQ. Is it fine? Any doubt so far, or if you want to ask me anything? No doubt?
No.
Okay. Okay. So now I'll suggest you go to the analyze menu, then go to the compare means, and then from here you can select one sample t-test. Analyze menu, compare means, and one sample t-test. You can select. Fine.
Yes, ma'am.
So I'm clicking on one sample t-test. Now you can, you are knowing this thing, your test variable is IQ, that you need to shift into the left box, into the right box. And in the test value, you need to give here the population mean. So usually the average mean is generally known as the 100, right? For a general or the layman, generally a particular person who is sound from mind, the minimum IQ should be 100. So we can say that average IQ should be 100 for any particular population. So I want to compare whether my sample is belonging to the same population in which the mean IQ is 100 or not, right? So that way I have shifted, or I have typed here 100 using my keyboard in the test value. Is it fine?
Yes, ma'am.
Then go to the options. Although you do not need to do anything here, you need to only check confidence interval percentages. It is 95%. Means 95% confidence interval meaning is 5% level of significance, right? If you want to make any changes, if you want to make it 90% or 99 something, that you can change here. But I am okay with 95%. I want to check my hypothesis at 5% level of significance. So that is why I'm going with this. And with this, I am pressing on continue. Is it fine?
Ma'am, I don't understand how you take this test value 100.
Okay, who is this? Who is asking?
Sweet.
Ma'am, usually for a generally it is the government reports, or generally this is the psychiatrist or psychologist generally suggest for a sound mind or for a sound person, IQ should be minimum 100. So we can say the average IQ is generally 100. So you need to always, because this is, as I have shown you in the slides, it is a hypothesized mean. You need to assume population mean, right?
Okay.
Fine?
Yes, ma'am.
Yeah. And then you can press OK to generate your outputs. So once I have pressed OK, outputs are coming in the output window. You can see first table is indicating the total means the size of the sample, the mean IQ value, and the standard deviation of IQ, right? This is the standard error of mean. Coming to the next portion, which is giving us the t value, you can see here P value is coming as 9.499. For the degrees of freedom, 29. It would be n minus 1. So 30 minus 1, 29. P value or significant value is coming as 0.00, which is less than 0.05. So if significant value is less than 0.05, so what we will do, whether we are accepting or rejecting hypothesis, we will do not accept the null hypothesis. Is it?
Yes, P value is less than. Yes, ma'am.
Yes. So we are not going to accept a null hypothesis. And what would be the null hypothesis in this case? Yes.
There's no difference between the normal IQ and the sample IQ.
Yes, we can
Am I
make the yes, we can make the hypothesis. There is no significant difference in the mean sample IQ and the population IQ, right? So
Yes.
here so here we are not going with the null hypothesis, means we can say that the sample IQ and the population IQ is different, or there is a significant difference in the mean sample IQ and population IQ. And we can see sample IQ mean value is coming as 108, and we have given the population mean as 100. So we can find there is a difference, but whether this difference is significant or not, so we have ascertained that this difference is significant using the one sample t-test. Is it okay? Is it okay?
Yes, ma'am.
Yes. So I think this is all from my side. Give me a second. I need to check whether I just a minute. Okay, may I create a poll? Yes, I think today sir has given me the option of creating a poll. I hope I can create, right? You people are okay? Can we create, do a this type of thing, poll or something? Can I do?
Yes, ma'am.
Yes.
Yes, ma'am.
Thank you. So I am putting the first poll for all of you. Give me a second. I'm just typing few figures. Okay, first poll I have launched. I think you can go and check. Eleven votes we have received so far.
Mm.
16 votes.
Yeah, I didn't open the poll. I forgot how to go to the poll section.
Sorry, ma'am.
I couldn't go to the poll section.
Ma'am, in the
That's where
activities, you can go.
Yeah. Yesterday I gone to that. So today I
Yes,
forgot.
yes,
Okay,
yes, yes.
activities.
No
Okay.
issues, no issues.
Thank you.
Ma'am. Yeah. 17 votes we have got. I am ending the poll, right? And I'll tell you the results. So the question was, descriptive statistics does not include mean, median, t-test, none of the above. So the correct answer was t-test. 11 of you out of 18 votes, 11 votes are correct for the t-test. One person has given the vote for mean and 5 have given the vote for none of the above. Okay, now I am launching the second poll. So you can check the next poll which I have launched.
Mm.
9 votes we have received so far, 11. Okay, 14, that's good. Okay, 17 votes. I'm stopping, ending the poll, right? So the question was, which graph is suitable for a categorical variable? Pi, scatter plot, histogram, or box plot. So we have received 70 votes. Out of that, 12 votes are correct. The answer is pi. So for categorical variable, out of the given choices, pi is the correct option, right? Histogram and box plots are not correct answer. Now I am launching the third poll. And after that, one more poll I'll launch. So total 4 polls I'm launching today. Uh, 12 responses we have received so far. Fourteen responses so far. Please answer the poll. 18 responses, very good. Not bad. 19 responses, very good. Okay, I am ending the poll. We have received total 19 votes. Now, question was, histogram can be used for numeric variable, nominal variable, categorical, or the none of the above. So 16 out of 19 votes, 16 of the votes are correct. For the numeric variable, we are plotting the histogram. The wrong answer is nominal variable. 3 votes we have received for it also, right? Now the last poll I am launching based on the t-test. I have launched the poll. You can see, you can check. Okay, great. Received 6 responses so far. Very good. 10 responses. 11. Great. 12. 14. Good. 15. Wow, great. 18. Very good. 19. Very good. Okay, I think please respond. We have received 19 votes, 20 votes. Very good. I think the highest vote we have got for this particular poll. I'm ending the poll now. I ended the poll. Question was, which variable is appropriate for one sample t-test? Options were numeric, ordinal, categorical, none of the above. So 9 of you have given the correct answer. Numeric is the correct answer. 3 votes gone for the ordinal and 8 for the categorical. Okay. So I hope you people have gained some insight using these particular polls which I have created for all of you, and I tried a lot
Ma'am,
to
can you
explain you.
please discuss the answer of poll number 3?
Just a minute. I need to check it. What was that? Poll number
Histogram
3.
can be used for, ma'am.
Yeah, histogram can be used for numeric variable, nominal variable, categorical variable, none of the above. So, ma'am, as I have told you, usually histogram we are using for the quantitative variable, for interval or ratio scale, or for numeric variable. Nominal scale variable means when we are having gender or something. So, for such kind of variable, it is not appropriate. Is it clear?
Yes, ma'am. Thank you, ma'am.
Welcome. So I think this is all from my side. If you can switch on your cameras, I can capture your pics. Thank you, Anchal ma'am. Thank you, Prema ma'am. Oh, that's great. How are you, Grija ma'am?
Thank you.
Thank you, Prema ma'am. Thank you, Girija ma'am. Anchal ma'am. Best Shakhi. I think it's Best Shakhi. Okay, ma'am, you are from Calcutta or somewhere? Yes. Yes. Thank you so much. I have captured your pics. Thank you. So this is all
Thank
from
you.
my side. Thank you. This is all from my side for the day. We will meet tomorrow and I'll discuss remaining 2 t-tests, that is independent samples and the paired samples t-test. I'll discuss tomorrow, and after that we will go for ANOVA, and last day I'll take the last test, that is the correlation and regression. Okay, fine.
Okay,
Yes.
ma'am. Thank you.
Yeah, thank you. Good night, everyone.
Thank you, ma'am.
Take care.
Thank
Yeah,
you,
bye.
ma'am. Good
Bye.
night.
Good night. Bye bye.
Thank you,
Pratima ma'am,
Suchana
just
ma'am.
a minute.
Thank you,
Pratima
ma'am.
ma'am, I need to capture you. Just a minute. Hi. Hi, Ajay sir, I am listening you. Yes. Ajay sir?
Yes, ma'am.
Yes, sir.
Thank you.
Thank you, ma'am.
Okay, ma'am. Thank you so much.
Thank you, sir. Thank you, everyone. Good night, everyone. We will meet tomorrow. Yes.
Thank you to
Bye.
you too, ma'am. Bye.
Yeah. Bye.
Thank you, ma'am. Good night.
Thank you, Gurja ma'am. Bye.